Our topic for this video is a review of solving quadratic equations. I'm not going to go back through all the different methods and all the details because we spent weeks on that in algebra last year. If you need a refresher on any of the methods like quadratic formula, completing the square, solving by square roots, or factoring, you can either look back at last year's algebra videos on our algebra channel or go to Khan Academy, or find other resources where you look up solving quadratic equations and the different methods to do that. What I'm going to do in this video is just go through the example problems that we did in class so that you have an idea of just a little bit of the problems from today's work. So we have several different problems here, numbers 1, 3, 6, 7, and 20. I picked these because we can use different methods and get a variety of ways to solve these. So the first one, 5k squared plus 28 equals 27k, is pretty ugly. It doesn't look well suited to completing the square. It doesn't look like a perfect square. So the only ways I'm going to be able to solve this are by factoring or quadratic formula. So I'm going to check first to see if I can find factors, because that is a little bit faster of a method and less prone to making mistakes than the quadratic formula. So I'm going to bring my 27k over here to get this in standard form. So now I have my ax squared plus bx plus c equals 0. And I'm going to use that in order to try to find factors. To do that, I find a times c. So I set up 5 times 28 is 140. And what I'm looking for is two factors of this that by subtraction, because this is a minus symbol in the middle, make 27. So I have 1 and 140. By subtraction, those make 139. I have 2 and 70. By subtraction, those make 68. So I'm getting closer, right? The closer these numbers get, the smaller that number gets. 3 doesn't divide into that, 4 does divide into that, so that's 4 times 35. By subtraction, those make 31, so I'm getting pretty close, so if we're going to find factors, it should be soon. 5 divides into that 28 times. By subtraction, that makes 23, so we skip from 31 down to 23, meaning there is no pair of factors that's going to subtract to make 27. So we're going to need to solve this one by the quadratic formula instead because we couldn't find factors that worked out. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to just plug in our a, b, and c. So a is 5, b is negative 27, and c is 28. We're going to plug those numbers into this formula. So negative 27, if we have negative b, that's going to be a positive 27. And we have plus or minus the square root of b squared. 27 squared. So this is one reason factoring is preferable, because now, especially without calculators, we got to do this by hand. 27 times 27, that's 49, carry over 4, that's 14, so that's 18. And we got a 0. 2 times 7 is 14, carry over 1, 2 times 2 is 4, plus 1 is 5. So that looks like 729. So 729 minus 4 times a times c. So 4 times a, that's 20 times 28. So 20 times 28 is going to be 0, 160, 0, 40, 0, 60. That's not right. 0, 16, 0, 0, 4. 20 times 20 is 400. Okay, so that's going to be 560. And we're going to divide that by 2 times a, so there's a 10 here. Okay, so we've got 729 minus 560, so we can rewrite this 27 plus or minus the square root of, that's going to be 169, that would be 600, 720, yep, 169 divided by 10. So that is our two roots, 27 plus square root of 169 over 10 and 27 minus square root of 169 over 10. We do need to make sure that we can't simplify this radical though. So let's look at the square root of 169. That is divisible by not 2, not 3, not 4, not 5, not 6, not 7, not 8, not 9. I'm not sure that's divisible by anything. 13, I think it's divisible by 13. So 13 times 13. That's a perfect square. We probably should have known that. I'm not always good with my perfect squares. We only had to memorize through 12 when I was in school. So 169 is the perfect square of 13. So we've got, this is 27 plus or minus 13 over 10. So now this is two different answers. We need to separate the plus and the minus. So one answer is 27 plus 13 over 10. The other answer is 27 minus 13 over 10. So 27 plus 13, that's 40 over 10. So this answer is x equals 4. Our other answer, 27 minus 13, that's 14 over 10. So we could write that as 7/5, right? 14 over 10 is 7 over 5. Or we could write it as 1.4 if we were writing a decimal, but especially when we're not using calculators, I prefer for us to leave these things as fractions. So x equals 4 and 7 over 5, or 1.4. So pretty rough doing all that by hand, especially with these big numbers, but we can do it, not a problem. So that's an example of solving by quadratic formula. If we had been able to factor it, it would have kept us from having to work with some of those big, terrible numbers, which is preferable when we're working by hand. Okay, so second one, we have x squared minus 49 equals 0. This one doesn't have a b term, so in our standard form of ax squared plus bx plus c, we only have the a part and the c part. There's no b. What that means is this should be solved by taking a square root. So we're going to move the 49 over and get x squared equals 49. And then we're going to just square root both sides. That gives us x equals plus or minus the square root of 49, which happens to be 7. So here x equals 7 and x equals negative 7. Those are our two answers. So that means that our zeros, if we drew our graph, would be at 7 and negative 7, and it would look something like that as a parabola. Okay, so number 6, we have, first of all, I see that 9, negative 12, and 12 are all divisible by 3. So before I do anything else towards solving this, I want to divide out that common denominator and just divide this whole equation by 3. That's going to give me 3x squared plus, no, minus, not plus, 3x squared minus 4x plus 4 equals 0. So we divided everything in the equation by 3 so that it's now a bit smaller and easier to work with. Now, again, I can't use completing the square, or I could, but I don't want to because my a term isn't equal to 1. We'll see an example of that in number 7 next. So again, just like the first problem, we're back to either factoring or quadratic formula. So let's see if we can factor this first of all. So we're going to try to find two factors of a times c, that's 12, which subtract, because there's a minus here, to make 4. So our factors are 1 and 12, those subtract to make 11. 2 and 6, those subtract to make 4. So those are our correct factors. Now that we have that, I'm going to go back to the area model that we used last year in algebra, and we're going to try to find our factors here. So we have 3x squared, and then what we've just determined is that our two corner boxes are a 2x and a 6x. So we have 2x in one corner and 6x in the other, and we have a 12 there. Hold on. So let's factor those. So the common factor of 3x squared and 6x that's going to come out to the front here is 3x. Our factor here is just x, because 3x squared and 2x, the only factor they have is x. So now we can see 3x times x makes 3x squared. Now to make 6x, I need a 2 here, and I need a 2 here to make x times 2 equals 2x. And then we end up with our 4 here, which is what we were supposed to have. Not 12. 12 was in the original equation. In our modified equation, we were supposed to have a 4 there. So perfect. That all works out just right. Now our factors are x plus 2 times 3x plus 2. So x plus 2 times 3x plus 2. Those are our factors, but our solutions are what we can plug in for x to make this equal 0. Because remember, we have an equation here where this thing all equals 0. So the first way to make this be 0, if I plug in -2 here, this term becomes 0, and 0 times anything is 0. So -2 is one of my solutions. The other one is whatever I can plug in for x here to make this term equal to 0. So 3x plus 2, if I want that to be 0, and I want to solve for what x goes in there, I would subtract 2 from both sides and get 3x equals -2, and divide by 3 to get x equals -2/3. So 2 and -2/3 are my two x values that are my solutions for this quadratic equation. And if we want to check that, you can always go back and plug in those numbers for x and see if it's true. Does it actually equal 0? So we could plug in -2 and this should come out to 0. We could plug in -2/3, this should come out to 0. I'm not going to do that here just for the sake of time. Okay, number 7. This one does have a b term, so we're not going to factor by square roots, or we're not going to solve by square roots. But this one has an a value, so in front of the squared term, of 1, and a b term that is even. So if we have an a equal to 1 and b is even, then we can solve by completing the square. We could still use factoring or the quadratic formula, but completing the square is like a quicker, more efficient way of solving the problems when we have this set up. So we're going to basically get the a and b by themselves. So we're going to do a squared minus 10a. We're going to leave some space there for when we complete the square, and that's equal to -52. So the idea of completing the square is for what's on the left to become a perfect square trinomial. In order to do that, we need to take half of this b term, which is -5, and square it. So -5 squared means that we need to add 25 here for this to become a perfect square trinomial. Since we add 25 over here, we also need to add the same number over here. So a squared minus 10a plus 25 is a perfect square of a minus 5 squared. So we put in the 25 so that that would work out, so that this negative 5 doubled is negative 10, and the negative 5 squared is 25. So we forced that into this pattern for a perfect square trinomial. That's going to be equal to the sum of these, which is negative 27. Then we're going to take the square root of both sides, and we run into a problem. So on the left, we get a minus 5, and on the right, we get plus or minus the square root of negative 27. And we can't deal with negative square roots. You won't learn about that until Algebra 2 next year. So in Algebra 2, you'll learn about how to take the square root of a negative number and finish solving this problem. But for this year, we're just going to say the key phrase we learned in algebra, which is no real roots. So anytime we end up taking the square root of a negative, that means that our parabola, wherever it is, never touches the x-axis. So when we're trying to find the values where it does touch, we end up with a problem. We can't find them. So the square root of negative number means your parabola never touches the x-axis, and we put as an answer no real roots. Okay, so for our last one, we have a similar pattern to what we had here in number 7. We have a negative as our an even number for b and an a value of 1. So we have 1x squared and negative 8x. So we can complete the square, but first we should check, does this 16 already make it a perfect square? So half of this is negative 4. Squared means our ideal c term is 16, which it's already there. So this is a perfect square trinomial of x minus 4 squared. We don't even need to complete the square. It's already completed for us. So x minus 4 squared equals 0. We square root both sides, just like we tried to do here. And we get x minus 4 equals, normally this would be plus or minus that, but 0 doesn't have sign, so it's just 0. So we get x minus 4 equals 0, and x equals 4. So we only get a single answer here. And if you'll recall from algebra, what that means is that x equals 4 is what we call a double root. So that means the parabola touches at 4 and turns around right there. So instead of passing through the x-axis and coming back up and making two different roots, it just touches down there and makes that single root, which is a double root at 4. So that's a reminder of how we work on quadratics. Again, if you don't remember these methods and don't remember how to do completing the square, quadratic formula, and factoring, definitely look back at those from last year or from other sources to review that.